Yeah, so this is a presentation about what it would take to live on Mars and why that might or might not be a good idea, why it might or might not be really kind of possible. And so when I was putting this together and looking through all the plans and all of the work that goes into making, trying to solve the problems of traveling to Mars, trying to solve the problems of living on Mars, I realized that essentially what I'm saying with this talk is please send me to Mars. I would like to go. I think it would be really fun. I think I would be a great candidate. I think this is a perfect idea. So there is a little bit of that bent to this talk. This is a picture of the Curiosity rover on Mars. This is me on a simulated Mars surface. I clearly fit right in. I think this is a good plan. Okay, so why Mars? Why is this the place we're talking about? Why is this what we're thinking about? Well, there are a lot of similarities between Earth and Mars. The size is comparable. Mars is about half as big as the Earth, and it has somewhere around a third of the surface gravity. So it's different, but there's a lot in common. It's also kind of nearby as planets go. It's the next planet out, sort of right next door. It's not immediately lethal, which is not something you can say about other planets. You could, if you took certain precautions, go to Mars, stand around, in a protective suit, and you're not going to die just by standing there. And it is beautiful. It's a gorgeous, amazing planet, and you look at pictures of it and you just want to go for a hike, right? This is one of the first images sent back from Mars Curiosity of the hills of Mount Sharp, and it looks like the kind of desert landscape you might find in the Southwest in the US. It's just gorgeous. And you see these pictures. This is another image from this one's from, I think, Opportunity or Spirit. I'm not sure, one of the other rovers, but you see these sort of stones and these long hills and valleys, and it just looks like a place. It looks familiar. It looks like somewhere you could go, somewhere that has a human scale, built in. Just as a side note, Venus is not recommended as a destination. We have sent things to Venus. We've sent a couple of rovers, or not rovers, landers to Venus. This is an image from the Venera 13 lander. And this, they got color images. This is a little piece of the surface of Venus. And at first glance, it looks a little bit similar. You've got the dirt and the rocks, the kind of same deal. But it's the surface conditions on Venus are actually immediately lethal. So the temperature there, it's the hottest place in the solar system. It's 465 Celsius on the surface, which is, they say, you can melt lead. It's the temperature of a self-cleaning oven. It's extraordinarily hot. And in addition to that, it's extremely high pressure. It's the same atmospheric pressure as you would have sort of water pressure under 900 meters of ocean, right? So it would absolutely crush and incinerate you immediately, no matter what you do. In fact, it's crushed and incinerated all of the landers that have been sent there. This one, Venera 13, I think is the longest functioning lander that's ever been to Venus, and it lasted 127 minutes. It's not even clear how, in principle, to make something that would last longer than that, given the crushing temperatures and pressures that exist there. People have talked about doing some kind of like clockwork rover that would be kind of more robust, because any kind of electronics basically is just destroyed immediately. So that's a challenge. So, Mars is better. And I should say just briefly, there is discussion about sending stuff to the clouds in Venus, like the atmosphere of Venus, because there are places in the atmosphere of Venus that do have sort of Earth-like conditions in the sense of a reasonable amount of atmospheric pressure and temperature if you go way up in the atmosphere. So you could do sort of these floating cities. That's something for the future. I think it would be really cool. But in the meantime, Mars is a place that has a surface, that has conditions on the surface that will not kill you immediately. And there's also some really interesting evidence that Mars was habitable in the past, in the sense of having liquid water on the surface, and a much thicker atmosphere. So this is an image from the Curiosity rover of a little bit of rock outcropping from Gale Crater, which looks like it was a stream bed in the past. There's evidence that there was a little bit of flowing water right there in the past. Here's another picture from Mars Curiosity from 2014, where you can see these layers, this stratification that appears to have come from, dirt sort of laid down in a lake, some kind of body of water over many, many years. So there is quite a bit of evidence that it had water in the past, and there are some nice, you can do some nice sort of visualizations of what that might have looked like. This is a visualization of Jezero Crater 3.5 billion years ago, when there probably was liquid water pooled on the surface and water flowing through channels in these lakes and rivers, and deltas. And the reason that we are intrigued by this is that everywhere we look on Earth, if there is liquid water, there is life. And we know that the sort of building blocks of life are pretty ubiquitous in space. The kind of, molecules and even amino acids that are the building blocks of life here on Earth appear to exist in a lot of places in the universe. We've seen amino acids in comets. We've seen lots of these sort of organic molecules, organic meaning carbon-containing molecules on other bodies in the solar system. And so it seems like there's a reasonable chance that if life starts wherever it can in the universe, which is an unknown, then there was a time in Mars's past where there were the conditions that could make life viable. And if those molecules were there, if there was enough time, then it's possible that in some of those lakes and rivers, some kind of life may have begun. Of course, Mars doesn't look like this now. This is an image of Jezero Crater 6 months ago, taken by the Mars Express orbiter. And you can still see that delta. You can see where the water was flowing in to that lake, but it is dry now. And one of the big mysteries about Mars is what did that change look like? We have a good idea of why it happened. Basically, the atmosphere of Mars was lost. So I'll talk a little bit more about that in a bit. But when the atmosphere was lost, that also led to the water being lost, and led to the conditions we have on Mars now, which is a very thin atmosphere with no liquid water on the surface. But the fact that there was water there and there could have been life that formed in those lakes and rivers and stream beds suggests that maybe there's something that we could find. Maybe we could find some sign of that life, some fossils. Maybe there's even some still there, maybe buried under the surface a little bit. There are some microbes living on Mars. And that makes us really keen to explore places like this, where we think that life might have been. And so here's a picture of Jezero Crater from last month, from the Mars Perseverance rover that just landed there. And here's a picture of it from yesterday. We are getting images back from this rover every day as the rover goes around and studies the rocks there. And it's going to be doing some really amazing other exploration with digging holes and lasering things, and it's going to send up a little helicopter to rove around and to fly around and take some pictures. And it's a really incredible machine. This is another image from the Perseverance rover as it was landing on Mars. And I'll talk a little bit about how that happened as well in just a bit. But it's a really incredible machine. And these robotic explorers that we're sending to Mars are just teaching us an amazing amount. So what does it take to actually get there? It's not easy to cross that kind of distance. There are sort of three things that you need to do to get to Mars. First, you need to escape the Earth. You need to survive the journey, and then you need to, land, preferably softly. This animation here is of a kind of orbit that would be a kind of trajectory that would be a favorable one to use, where you use the alignments of Earth and Mars, Earth being the one in the inner circle there and Mars being the one in the outer circle. And you use the sort of momentum to get the spacecraft heading toward Mars, catching up to it at the right time. And that's the sort of quickest way to get a spacecraft to Mars, or the sort of minimum energy one. And that alignment where you can use that orbit happens about every 25 months, which means that there's like a Mars season, right? And so that's why something like 6 or 7 months ago, everybody seemed to be throwing things at Mars. And so there were missions sent from a few different countries, sending things to Mars because they were using that nice alignment. And so what that means is that you have the option of sending things there during that window and then sending them back kind of on the other side of it. And so that gives you kind of a minimum time to get there and a minimum time to stay there before it's convenient to come back. And so I'll talk a little bit about that in a bit. Now, how do you get something off of Earth, escaping the Earth's gravity enough to get to Mars? It takes quite a lot of sort of firepower to do that. These are a few of the rockets that have been proposed to do this. The one on the far left is the SLS, the NASA's Space Launch System rocket that they're developing, in an attempt to get a human mission out there. On the far right is the Starship rocket from SpaceX, and I'll talk a little bit about that in a bit. In the middle there is the Saturn V, which sent people to the moon. So you can see that it takes a lot to actually escape Earth. If you're only sending things to low Earth orbit, you don't need quite as big a rocket, because you don't actually need to achieve escape velocity from the Earth. You can go a little bit. It takes a little bit less sort of lift to get just to low Earth orbit. But if you want to get to Mars, you need a really big rocket, basically. And here's a sort of visualization of the Space Launch System as it may appear when it actually gets going. The second step is to survive the journey, and this is non-trivial. Okay, this is a really difficult problem, and it's a difficult problem for a number of reasons. One is that it's probably going to be kind of a small capsule, because again, it's very hard to get things into those kinds of orbits. So it's hard to get things out of the Earth's orbit. So you need really big rockets, and ideally not a very big payload. And so that's just a difficult thing. If you, it's very difficult to send a large rocket. So it's probably going to be confined space, and it's going to take 6 to 9 months or something to get there. So you're going to be a few people in a small space for quite a long time. And there are a number of kind of hazards that come with that kind of space travel. So there was a nice set of sort of infographic and set of information put out by NASA a little while ago that just kind of details all of the ways that space can seriously mess you up. And so I'll walk through these a bit. So there's the lack of gravity. We rely on the gravity of the Earth to do a lot for us as sort of human biological creatures. And if you don't have that gravity kind of pulling you down and making your muscles work, and sort of putting pressure on your bones and all of that, bad things happen to your body. And we know this because we've had people in low Earth orbit for a really long time. So you get things like loss of bone mineral, loss of muscle, you get kidney stones, general disorientation, vision problems. A lot of the astronauts who've been in space for a long time come back with problems with their eyesight. The ickiest one that I've read is that little bits of you can start falling off. So it turns out that a lot of astronauts lose their fingernails when doing spacewalks, because when you are working in that environment, you have to wear these really thick, hard gloves, and the pressure of the gloves against your fingernails can be such that you can actually like break off your fingernails from doing spacewalks. It's just so gross. So a lot of really bad things can happen to your body from being in a gravity-free environment in space. And it's not, you're not gravity-free. Obviously, gravity is everywhere. When you are in a microgravity environment, when you don't have the kind of gravity that you have on a planet. So there's just the difficulty of dealing with that. And on the space station, they do things like they do something like 2 hours of exercise per day just to keep the bone density up, to keep the muscle mass. So there are ways you can try to deal with it, things like spinning the spacecraft to give you a simulation of gravity, but it's a challenge. It's actually a really big deal. Another challenge is just the closed environment. So you can get things like bacteria and disease transfer can be more efficient in these kinds of closed system environments. People have allergy problems sometimes. And then there's just general stress related issues of being in a closed space. So that's not trivial either. And I'll talk a little bit more about the ways that we're trying to sort that out with missions, sort of here on Earth. Then there's the space radiation problem. When you are outside of the Earth's atmosphere, outside the Van Allen belts, you are in a much more exposed sort of environment when it comes to space radiation. So things like cosmic rays, solar radiation. If there's a coronal mass ejection, that could be really bad. So if the sun put out a bunch of plasma and radiation, that could be really difficult. And you can get these really high doses of radiation when you're out there. And it's hard to shield from that. You have to have really thick walls on your spacecraft, which means lifting more mass, which is hard. Or you can maybe line the spacecraft with water. That's potentially can be helpful, but it's not an easy problem actually. So you can expect that people who take these really long duration space flights outside of low Earth orbit might end up with radiation sickness, nervous system damage, cancer. There's a lot that could go wrong in terms of the space radiation. And then just like distance from Earth is a problem. You can't you can't sort of restock something if you don't have enough of it. You don't have the local expertise, and there's a communication delay. When you're going to Mars, you can have something like 20 minutes communication delay, and so you can't even get immediate feedback if you need to ask a question if something's going terribly wrong, if there's emergency. So that brings its own hazard. And then the isolation and confinement can be a really big problem in terms of just causing psychological problems, crew conflicts, putting people together in a little box causes stress. And this is something that I know a lot of us are realizing during the pandemic, is that being in a small space with other people for a very long time can be really challenging to deal with. So one of the ways that space agencies are trying to mitigate that issue is through simulated missions, where you just take a bunch of people and put them into a closed environment for a long time and see how they do. Right? This is an experiment to figure out what the psychological challenges are and how you can deal with them. So this is one, the Mars 500 mission from ESA, where they took 6 men and put them into this habitat for 520 days. It was a facility in Moscow They gave them a 20-minute communication delay from the sort of headquarters just to simulate that challenge. They gave them the kind of food that they would get on something like the space station, something like the space station, to simulate what it would be like to be eating that kind of food for that long a time. And so there were 6 men in this study, and 4 of them had some kind of sleep loss or psychological issues. Only 2 sort of really adapted well to the mission. It was just a really rough time. I mean, it's a long time to be stuck in a small space. One of the researchers studying this said only 2 of the men adapted well to the mission. Of the other 4, there was at least one major reason for concern, where we would ask, should we really send someone like this on a long mission? Now, you have to imagine, like, they vetted these guys, right? Like, this wasn't just that they grabbed people off the street and said, we're going to put you in a box for 520 days. This was, highly qualified people who signed up for this, who were put through all the psychological tests, and they still had, a really tough time. And 4 of them had major problems. So this is not a small problem. This is maybe one of the biggest problems in terms of sending people to Mars, is figuring out how to keep everybody healthy and sane on the way there, and making sure that there aren't big problems. Now, one thing you could say as a counterpoint, these guys were in basically boxes in a facility in Moscow, right? If you are actually en route to Mars, you have a different view and you have a different goal. And so there is a psychological difference between saying we're going to put you in a box in a facility versus you're going to be in space, you're going to be seeing the Earth from above, you're going to be getting these views that very few other humans have ever had. Especially if you get to Mars, you see something that really nobody has ever seen. And there's some really amazing, there's sort of anecdotal evidence that having this kind of perspective changes somebody in a really good way. There's something known as the overview effect that astronauts experience, where it's been described as sort of a feeling of global consciousness, or a sort of connection with the world, an urge to make the world better. This idea that once you get off of the Earth and see it from the outside, it changes your perspective, and it really changes how you feel about humanity, about our place in the universe, and so on. So it's not going to be the same experience, but that said, it is going to be a long time in a small space, and that is something that's going to need to be dealt with. So the final step is to land softly, to make it to Mars, and to get there safely, and to get to the surface without dying. And this is not easy. Something like half to 2/3 of missions to Mars have failed, and failed in the sense of crashing, not surviving the trip to the surface. And there's a reason for that, is that the atmosphere of Mars is just thick enough to cause problems, but not thick enough to give solutions. Okay, so what I mean by that is, it's thick enough that if you're coming in to land, you have to deal with it, or your spacecraft burns up on the way down, right? So you need like a heat shield. You need to deal with the atmosphere. You need to deal with the heating that's going to come when you're plummeting toward the planet. But it's not thick enough to give you enough of a slowdown with parachutes that you can just kind of parachute down like you would if you were coming back to the Earth from space. So if you're coming back to the Earth from the moon or something, you use the heat shield to slow down through the upper atmosphere, and then you open up the parachute and you can sort of coast down to the surface. That doesn't work on Mars. There's not enough atmosphere to give you a terminal velocity that is low enough to be survivable. There are a number of things that NASA missions have done to deal with this, and And NASA is the only organization that's gotten things to land like safely and make it to Mars in one piece. Is interesting. But the way that they've done that is in the case of the Mars exploration rovers, they were fairly small. So the way that they did it was they had a parachute they had the heat shield first, to come through the atmosphere. Then they had a parachute to slow it down a bit. Then they had these sort of retro rockets, and they put the spacecraft itself in this sort of balloon ball sort of a configuration. So they put sort of cushions all around it, and they just let it bounce along the surface until it stopped. And then they opened it up, and the spacecraft, the rover, kind of rolled out. So that's something you can do if it's a fairly low mass object. If it's bigger, then those cushions are not going to work, and you need something more elaborate. So that's how you get the sky crane. So the sky crane is what was used for the Mars Curiosity rover and the Mars Perseverance rover, and it involves a heat shield, and then a parachute, and then this sky crane thing, which it's this machine that has rockets, and it lowers the spacecraft down, the rover down, and then lets the rover come down and flies away. I'm going to show a video of this. So we actually have a video of this happening for the Perseverance rover, which is incredible. So this is showing the parachute coming out, the supersonic parachute opening up. And this is all video from the rover itself, taken as this was all happening, and then sent back. This is the heat shield being dropped onto the surface, and so you can see this is when the rover is still hanging from the parachute, so it's kind of waving from the parachute, and the heat shield is dropping away, and that's the surface of Mars as the spacecraft is slowly coming down on that parachute. Now, again, it's not coming down slowly enough that it could go all the way down with just the parachute, but that has slowed it down a bit. One of the amazing new things about the Perseverance rover is that as it was coming down on that parachute, the rover was taking pictures of the surface. Now, this is the video, but it had another way of taking images of the surface and sort of very quickly mapping the surface features and comparing it to a map that it had that had been sort of drawn out to show where the most hazardous or the least hazardous places to land would be. And so what the spacecraft was able to do was to choose a landing site within this sort of region that it was moving toward, and decide on a specific landing site that it thought would be, the most favorable, the least dangerous landing site. And so it had little sort of directional rockets that were connected to the sky crane thing that could sort of steer it a little bit. So here it's disconnected from the parachute. It's coming down on the sky crane with these rockets, and it's steering itself toward the part of the surface that it thinks will be, sort of nice and flat enough, and not the side of a dune, and not the edge of a crater. And so then it's coming down to the surface, and you can see it starting to kick up dust. And at that point, it's about to be lowered on that cable. And so you can see here it being lowered. So you can see the view up toward the sky crane and down toward the rover. As it comes down, the wheels sort of open up, and it finally lands on the surface. It's just an absolutely incredible achievement. And there you can see the sky crane flying away to go, sort of crash somewhere else. It's still amazing to me that this is possible, that they actually pulled this off twice, once with Curiosity and once with Perseverance. It's an incredible thing that they did. Um, Unfortunately, if you're sending people, you can't do the sky crane. We're just too heavy if you want to put multiple humans on board. So the way it's going to have to work with people, if you want to actually send humans, is something like a rocket that lands vertically. You're going to have to do something with where the rocket itself is cushioning the landing in the sort of style of these SpaceX rockets. So we've probably all seen the Falcon 9 rockets come down and land on the drone ships or on the landing pads. Really amazing. And there's plans by SpaceX to build a much larger rocket called the Starship that would do the same kind of landing on Mars, but much bigger. So this thing. I'm going to show a little video of a trial run for one of these Starship rockets. It's something like 50 meters tall, and then it's on top. And then when it launches off the Earth, it'll be on top of a much larger rocket, sort of first stage rocket. But the part that lands on Mars is this thing. It's really big, and this is a video from March 3rd of the sort of 10th prototype of this Starship rocket. It went up to 10 kilometers and then came down and landed on the surface of the Earth in this case. So they were doing this trial run, and it was an incredible success. They actually got it to land. Unfortunately, it did blow up 8 minutes later. So there's still working out the problems with that, but there's reason to believe that this kind of landing is possible, right? That the technology is in development to make a rocket that could land vertically on Mars. So assuming that we get there, assuming that we land safely, we get a rocket to bring us down without killing us all, like what do you need to live there? So humans have just a few sort of basic needs for survival, right? So we need oxygen to breathe, water, food, shelter. We need to be able to sleep, these kinds of things. And Mars makes all of these difficult, right? Okay, so oxygen. The air on Mars is about 95% carbon dioxide. There's only a little bit of oxygen in the atmosphere of Mars. And it's also a very low pressure, just the atmosphere in general. So it's not easy to deal with that. We have to either bring our own air or make it on the surface, right? And I'll talk about some possibilities there, but we can't just go there and breathe the air. It's not possible. The other thing is water. So generally speaking, Mars is just too cold and too low pressure for liquid water to be on the surface. There's maybe some possibility for salty or briny water, and there's been some suggestions of maybe there's a little bit of that in some places on Mars where there could be a tiny amount of liquid water. But the problem is really more the pressure than the cold per se. Okay, so this is one of the more technical bits of the talk, but this is a phase diagram for water. So this is where if you have a certain pressure and a certain temperature, water can be in different phases, right? So if you have cold, low pressure, or high pressure, cold anywhere, you can get ice, right? Because so ice exists when water is very cold. If you have very hot water, it becomes steam. If you have really high pressure, then you can have even hot water be water. So depending on what you do with the pressure and the temperature, you get ice, water, or steam. And on the Earth, we have this kind of range of pressures at a range of temperatures, and roughly at 1 atmosphere of pressure for most of the surface, where you can have all 3 phases existing on the surface of the Earth, right? You can have water as steam or water vapor, you can have water as ice, and you can have liquid water. On Mars, the problem is not just that it's cold, but the pressure is so low that almost the entire surface is below this triple point, this place where water can exist in all 3 phases. So it does, the temperature on Mars does go above what we call freezing. At some places, at some times of year, it can be, well over what we consider the freezing point of water. But because the pressure is so low, instead of that water turning into liquid, instead of the ice turning into liquid water, the ice turns right into vapor, right? So there's ice on Mars, but it'll go straight from ice to water vapor and skip the liquid water. So having liquid water on the surface is a problem because of the pressure, not so much just because of the temperature. And I'll go back to that in a little while. Another problem is food. Okay, so the soil on Mars is likely kind of sterile due to the radiation and also some toxic compounds. So there's stuff like perchlorates, which is a kind of toxic compound that we know is present in the soil of Mars. So it's not easy to you can't just plant a thing and expect that it's going to grow. And then the shelter is an issue as well, because the surface is largely unprotected from radiation, right? The atmosphere is really thin. There's no global magnetic field. So the kinds of radiation protection we have here on the surface of the Earth, we just don't have on Mars. And so you're probably going to have to live underground. And how deep underground depends, but there's very little protection unless you are under something. So you have a similar problem as you have on the way to Mars, which is that you have all this radiation and there's not much you can do about it. Why Mars lost its magnetic field is an interesting question. It's thought that maybe, like, it probably had a magnetic field in the past. It's thought that maybe what happened is that the core of Mars kind of cooled down too quickly, and so it lost the dynamo, the sort of motion in the core that creates a global magnetic field. So for whatever reason, that it looks like that magnetic field turned off, and that may have contributed to the loss of the atmosphere by the solar wind. So the idea being that you could lose the magnetic field, and then the solar wind kind of strips the atmosphere away because it doesn't have that magnetic field protection. There are other ideas that maybe the atmosphere was lost in some other way, but in any case, somewhere around 4 billion years ago, maybe 3 billion years ago, the atmosphere started to deplete, and so now it's very, very thin. Another problem with the sort of shelter thing is that the dust on Mars is probably quite toxic, because there's a lot of it, and it's hard to deal with. So it's this very fine dust. And if you were walking around on the surface of Mars and you come back into your habitat and you take your boots off or whatever, that dust is going to be sort of kicked up in the atmosphere of your habitat, and you're going to have to deal with that somehow. And the dust is a big problem even for our robotic missions on Mars. So this is the Spirit lander, a rover that this is a solar-powered rover. The new ones, Curiosity and Perseverance, are nuclear powered, but this one was solar powered. And this is sort of just shortly after it landed, and this is 2 years later. And you can see that deposit of dust across the solar panels, and that can be a really big problem for some of these landers. One nice thing is that there are occasionally dust devils that come along and sort of sweep the dust off of these landers. So we've had some of these rovers get a reprieve due to sort of dust devils coming in and sort of wiping everything away. But the point is, there's a lot of dust in the air, and you don't want to breathe that stuff in. So that's going to be a problem. And then finally, the sleep thing is a bigger problem than you might think. So a day on Mars, it's called a sol, is 24 hours, 39 minutes, and 25 seconds long. And so if you move to Mars, it's kind of going to feel like you're always a little bit jet lagged because the day is just a little bit longer than you expect. So for example, let's say that you get there and, excuse me, on Sol 1, you wake up at a time that feels to you like 6 a.m. Then a week later on Sol 7, you're waking up at a time that feels like about 10 a.m. to you. So you're sort of shifting. In week 2, it's going to be, in the middle of the afternoon. In week 3, it's going to be in the evening. Week 4, it's the middle of the night. And then week 5, you've wrapped around again to the morning. And so it's kind of going to be like moving 2 time zones every 3 days, which is not, not something that's super healthy for a person, right? Jet lag is bad for you. It messes with your sort of sleep. It messes with your mind. We have people who actually have to live on these times. So if you are somebody who is very connected to the operations of one of these rovers, you might have to live on Mars time when you're doing your work, because none of the rovers do their work at night. Mostly just because it gets too cold. Like the nuclear powered ones, in principle, they could, but it actually, like, that would use up a lot of power. It's better for them to sort of recharge their batteries overnight and then work during the daytime. So if you need the rover to be operating during the daytime, and you need to be sending commands to it every day, every soul, I should say, then you need to be awake when the rover's awake, right? You need to be awake when it's daytime there. And so you need to live on Mars time. And so this is a tweet from one of the scientists currently living on Mars time at JPL. You're going to need to set your clock so that you're getting up about 40 minutes later every day, and you're going to be very quickly out of sync with whatever your local Earth time zone is, and it can really wreak havoc with your sort of lifestyle and your sleep patterns. So this is something to consider for moving to Mars. I think people would adapt, but anyway. Okay, so let's see what we can do about these things. So for oxygen, there's actually kind of a cool possibility being worked out right now, which is that the Perseverance rover has an instrument on it called MOXIE. And MOXIE is designed to break up CO2 from the atmosphere and make oxygen, O2. So it actually is, it's a sort of test run for what could be built into a larger project that could take the CO2 that's abundant in the atmosphere of Mars and make enough oxygen for human explorers to breathe. So, this is a test run at the moment. I think they don't have results from it yet, but it'll be interesting to see how well this works and whether this can be something that would be scaled up to support human travelers on Mars. Water is another interesting one. So we actually know there is quite a lot of ice on the surface of Mars. This is a map of sort of what's expected for the ice across the surface of Mars, where there's different kinds of sort of regolith, which is what you call the sort of dirt on Mars, different kinds of environments where you can have some ice within a few meters or even less than a meter of the surface. And there could be quite a lot. There's an estimate of maybe something like, in some places, 35 liters of water in the form of ice per cubic meter of Mars soil. So there are places where you can have quite a lot. This is a neat image from the Phoenix lander, and these two look very similar, right? So what's happened here is the lander has dug a little hole in the dirt, and it scraped down, and it's used this white stuff, and there are a couple of little like tiny little pebbles to on the left in the shadow of the left-hand image, and in the right-hand image they're not there. And those little pebbles are little bits of ice that were scraped up when the rover did its little scraping, and those little bits of ice sublimated between the two images. So that's not a deep hole, right? So there is ice very, very close to the surface of Mars, and in principle, it should be possible to take that ice and turn it into water for the purposes of drinking. Now, it's not easy because that ice is probably contaminated. You have to find a way to purify it, but water is there. It's just in the form of ice under the surface. Food is another thing that may be possible to deal with. So the kinds of nutrients that plants need do exist on Mars soil, as far as we know. So this is an image from NASA, obviously put out after the movie The Martian, talking about what it would take to grow plants in Mars soil. And as long as you could get rid of the toxic perchlorates and not have them end up in your food, you should be able to use that soil in some way. So it's possible, and maybe you'd have to enrich it with something from Earth, but the necessary chemicals are basically there. So it's not impossible, and the soil should be fairly rich because it's mostly volcanic, and that's the kind of soil that is very rich on Earth as well. So you can do that. And you might also find that the perchlorates are not uniformly distributed. It might not be as bad in some places as it is in others. Now, the shelter is an interesting issue. So as I said, the lack of the magnetic field, the lack of the atmosphere means that there's a lot of radiation coming down, and you need shielding for that. So for the most part, you're going to be living underground. You're going to be living in lava tubes, potentially. There are these sort of emptied out lava tubes on Mars that you might be able to find a sort of cave that was a lava tube that gives you a few meters of regolith above you to shield you from the the radiation. There was a neat concept art thing a few years ago where NASA was looking for suggestions for Mars habitats, and somebody came up with making kind of an ice house or sort of an igloo type structure. The idea there being that water is a pretty good shield, and you could also have kind of ice of light coming in as well. So if you found a way to create something out of water, let it freeze, cover it up so it doesn't sublimate into the atmosphere, you could potentially make a cool sort of ice house shelter on Mars and not have to be deep underground. But of course, that takes a lot more resources. So you're probably going to be living underground if you go to Mars. It's maybe not as glamorous as one might think. Every time I see a science fiction movie or something where they're just in kind of a hut, I think like that's pretty far out in terms of sci-fi, because you do need heavy shielding. You need a meter or more of rock or water to shield you from the radiation, such that you're not going to just die immediately. So it's going to be difficult, but maybe if you have enough resources, you could build something cool like this. Now, the sleep thing is another interesting issue. I mentioned that the day is something like 40 minutes longer than an Earth day. And what you might be able to do is find people for whom that's normal, right? So there are people who have sleep cycles that are not 24 hours long. In fact, most people have sleep cycles that are a little bit more than 24 hours. If you put somebody in a room with no windows and you just let them sleep, sync to their sort of natural cycles, on average, it's going to be something like 24.2 hours, right? So it's going to be a little bit longer than a 24-hour day anyway. There are some people who have longer cycles and have trouble adjusting to a 24-hour time period. And it's suggested that some people who are sort of extreme night owls have, that's what's going on with them, is that it's hard to get up in the morning because every day it feels earlier, right? And so there are people for whom that's kind of just normal. So that brings me to my my sort of side thing that obviously I should go. I'm a night person. I think I'd adjust just fine. I have other Mars qualifications. My eyesight's really good, so if it degrades, it's fine. It's not a big deal. I'm a good jumper. Because the gravity is so low, you're probably going to be doing a lot of jumping around. I used to do high jump in college. I like deserts. I've worked underground doing physics in underground mines. I'm cool with that. I've even qualified. I've even gotten to the highly qualified list for the astronaut program. I'm almost there, and I have a family history in space exploration. So as a brief aside here, this is my granddad, Willard Samuel Houston, and he saved the Apollo 11 mission, not by himself, but he was instrumental in making sure that Apollo 11 did not end in tragedy. So he was a meteorologist in the Navy in the 1960s. And one of the jobs that he had was to work with NASA to make sure that the weather at the splashdown site after Apollo 11 would be okay, right? So his job was to check that when this capsule comes back with the astronauts in it, it doesn't land in a storm or something like that. And so a few days before the mission was set to splash down, something like 72 hours before, he was looking through the images that were available of the weather at the splashdown site, and it all looked okay. But he also knew that he had access to some secret spy satellite data because of his work in the Navy. And he wanted to just check and make sure that those satellites, which had better images, didn't come up with anything weird. And so he went over and he talked to this guy, Major Hank Brandley, who was also involved in the spy satellite program. And they just met to find out, like, is there anything to be worried about? And this program was called the Corona Air Force Spy Satellite, and what they saw on the images was actually really concerning. They saw what's called screaming eagle thunderclouds. So these are thunderstorms that were so violent that if the capsule had come down at the place that it was originally planned, those thunderstorms could have easily torn the parachutes right off the capsule. And so when these two guys met, they knew that was the problem. And my granddad had to go back to NASA and tell them, you have to move the landing site. I cannot tell you why. And so NASA was like, okay, it's only 72 hours before splashdown. This is a big deal to move, to give the astronauts a new command, to have the splashdown site moved. This is not a small thing. We will do it because you say so, but we're also going to send some reconnaissance missions out to the original site. And if there's not a thunderstorm there, you're out, right? Like this is a big deal. So, as you know, the splashdown went fine. The astronauts survived it. Everybody was happy. NASA did send some mission, some planes out to the original site, and there were big thunderstorms. So fortunately, they listened to my granddad and they made the change because otherwise that would have been incredibly tragic. So anyway, that's just an aside. Let's move on to future Mars. So what are we actually doing in terms of going to Mars? What does it really take? Are we getting there? Is this happening? There are some plans in the works from NASA and other agencies to try to do that. This is an image from Rick Davis, who's part of NASA, who's sort of one of the people laying out what these missions would look like. There are a lot of pieces to this, right? So you need a launch vehicle, you need a crew vehicle for the part near the Earth, you need a vehicle to get to Mars, you need something to bring the cargo in, you need a good comm network, you need something to land, an ascent vehicle to get onto the surface, you need reconnaissance satellites to check out the surface, make sure everything's going to be okay. You need a surface spacesuit that's very well sealed to deal with the dust and everything. You need habitats, rovers, all of that. From what I understand, the sort of two things in the top left here, the launch vehicle and the near Earth crew vehicle, those are pretty far along in development. The rest of it is kind of still being worked out. There's questions as well about, should we do this, right? Should we go to Mars? Should we send people at all? Because once you send people, you are sending Earth life, and that Earth life is going to contaminate anything that might already be there. And not only is that going to, potentially, does that have sort of ethical implications for what it's doing to the life on the surface, it's also going to make it really hard to find that life and know that it's unique, right? Like when we send a rover right now, we sterilize that thing as well as we can, and we don't send it to places where we think that there's likely current life, although that's a little unclear, right? Because we don't know where there might be current life. But everything is very, very well sterilized, and especially Perseverance, because it was going to this delta where there could be something that's living there. Once you have people, all bets are off. People are going to have bacteria on them. They're going to have all sorts of little microbes, maybe extremophiles, like those tiny little things, sometimes called water bears. I can't remember the name for them at the moment, but there's these little tardigrades, these little creatures that can survive in the vacuum of space for quite a long time. We might end up contaminating the place with that. And there are also a lot of concerns about, the idea that this is a sort of colonization type of thing, where there's worries about just what the whole idea that we should just go to a new place and decide we live there now, right? So there's ethical concerns as well as the technical concerns. And then there's a question of, is Mars ever going to become more habitable? Like, can we terraform? Like, can we do something to change the atmosphere of Mars to make it more habitable? There's a suggestion recently I saw that said, like, in a billion years or something, Earth is going to be too hot because the sun will have brightened by then, and the habitable zone of the solar system, the part of the solar system where the temperature is good for liquid water on the surface of a planet, is going to move out. It's going to move out to the place where Mars is. Will Mars be better then? The answer to that is not really, because as I showed before with the phase diagram, unless the atmosphere thickens up, it'll just be a hot desert instead of a cold desert, because you still won't have enough atmosphere to have liquid water on the surface. So if you really want to terraform Mars, if you really want to make Mars like Earth in the sense of having liquid water and atmosphere, you need a much bigger intervention. You need to put a whole lot of carbon dioxide into the atmosphere. You need to do something like that that's actually quite hard and maybe impossible. There might just not be enough carbon dioxide on the planet itself to do that. Maybe you can throw some comets at it or something, but then you end up, risking ruining the atmosphere by just those impacts. It's not a small thing, right? So my impression, based on talking to people who are working on this stuff, who've thought a lot more about it than I have, is that Mars is the kind of place that will probably have outposts. We'll probably have scientific research outposts, much like Antarctica, where people go there to study stuff, to do science, to spend, weeks or months or years, but not sort of permanent settlements. I think it's unlikely that we'll have, in the near term, kind of multi-generational, habitats or places. Like, we're not going to move there and live there anytime soon. Maybe eventually there will be a time when people do have entire underground cities. But just, to be clear, Mars as a backup planet is not a good idea, because there's basically nothing that you could do to the Earth in terms of, climate change or nuclear winter or asteroid strikes or whatever that could make it less habitable than Mars is now, right? Mars is an incredibly challenging place, and at least on Earth, kind of no matter what you do to Earth, there's some breathable air, there's an atmosphere, there's a magnetic field, and those things are not available on Mars. So my personal opinion is that it'll probably be a very long time before there are long-term, habitats there. But I do think we'll go, and I kind of think we should, just to visit. And people have different opinions about that. I would like to go, and I think that it's part of human nature to want to explore in that way. I just want to leave you with a couple of images and words that make me think about this project of human exploration. This is an image of a sunset on Mars. Sunsets on Mars are blue rather than red because of the kinds of dust and other particles in the air that reflect light in a different way. It's a really beautiful and alien place. This is an image taken just after local sunset by the Curiosity rover in 2014. And I don't know if your screen resolution is good enough to see it, but there's a little dot in the sky in this image. And that little dot is the Earth. That is what we look like from the surface of Mars. There are a few images like this taken from the surface of Mars where we can see ourselves. And I want to just end with a couple of words from Carl Sagan's pale blue dot speech. So he wrote a speech about an image of Earth taken by the Voyager satellite from millions of miles away as the Voyager spacecraft was sort of heading out of the solar system. But I think that it applies pretty well to this too. He says, "That's home, that's us. There's nowhere else, at least in the near future, to which our species could migrate. Visit, yes. Settle, not yet. Like it or not, for the moment, the Earth is where we make our stand. It has been said that astronomy is a humbling and character-building experience. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known." So that's it. I will take some questions. Thank you very much.
Dr. Mack, thank you. That was awesome. Just so that you know,
Thanks.
it's 7 past.
Yes. Okay.
And so like, as long as you are available to continue hanging out and answering questions, like that's fine. Just
yeah, I think I will hang out for another sort of 10 or 15 minutes. Sorry, it went a little bit longer than we planned, but I'll answer a few questions, and if you need to take off, that's cool. There'll be a recording of this as well, so we'll include the Q&A in the recording. Okay, so there is a question. I'm just going to look through. Gosh, there are a lot of questions. Okay. I'll take a few of these sort of at random. Apologies if I don't get to yours. Okay, so Jake says, as a biologist, I'm always skeptical of claims that objects, especially objects with any kinds of nooks and crannies, can be sterilized 100%. Life is extremely resilient. I'm wondering if you can talk about what sterilization measures are taken and what conversations astronomers have about the possibility of contaminating Mars with Earth life. Yeah, it's a huge challenge. I think that there's an agency at NASA called Planetary Protection Agency, and they do the best they can with this. I don't know the details of exactly what procedures they use, but they do take this very seriously, and they do their very best to sterilize. But it is true that as soon as you have Earth technology, there is a very good chance that something will get there. You can hope that whatever it is dies on the way over, right? You can hope that through the vacuum of space, through the sort of trauma of launch and the passing through the atmosphere once you're there, and the heat of that, you can hope that something will kill whatever's left. But it is an issue, and it's very hard to say that we'll ever be able to actually get things perfectly clean. So, the Planetary Protection Organization does try to amp up the protections for things that will be in places like Mars where there could be life, but it's not 100%. So maybe we've already contaminated it, but it's going to be a lot worse when there are people. So it's a difficult thing. Let's see, what else should I get to? Lindsay asks, you said Mars is not very lethal. What is the most lethal planet for us? I think the surface of Venus is the most lethal place, because you will be crushed and incinerated very quickly, all at once if you step foot on Venus. The other planets, well, I mean, it's also, I don't know. I mean, I guess Jupiter and Saturn don't, and Uranus and Neptune don't really have surfaces at all. So it's hard to say what stepping foot on those would be like. Jupiter is pretty bad because it has really strong magnetic fields and a lot of radiation, and just getting into the sort of radiation zone of Jupiter is going to be a problem. Not to mention like the storms and everything. Once you get there, there's lightning and all that. So depending on what you mean by being on the planet, it's most of them will kill you pretty quickly. I think the least lethal ones are probably Mars, Mercury, if you choose the correct side of Mercury, because you don't want to be on the sun side because it's really hot. I mean, depending on what you consider a planet or a dwarf planet or whatever, some of the outer ones are potentially okay for just standing there in a really good suit. But Mars is certainly the best, the least lethal we can get for the moment, other than the Earth. Okay, what other questions have we got here? Somebody asks, how does wind factor into this? A smooth landing on Mars? Are we able to predict the weather and wind patterns on Mars? So the wind is, there are, weather patterns, there's sandstorms and things like that. But because the atmosphere is so thin, the wind is not going to be a really big issue, because it's just not going to have enough power to really cause problems. In the movie The Martian, there was a windstorm, sandstorm kind of situation that caused a big problem in the beginning of the film. And if you hear a talk by Andy Weir about that film, he'll say that that was one of the biggest sort of fudges that he made for the film, was to make that windstorm or sandstorm a bigger problem than it is. It actually wouldn't really cause those kinds of issues. So the wind should be all right, except in the sense of sort of moving dust around in ways that might be a problem. Let's see. Zafir asks, do you think there used to be life on Mars, possibly intelligent beings? We don't know. I think it seems unlikely, because we haven't seen any signs of like artifacts, but it's hard to say, right? Like, what does intelligence even mean? We haven't seen any definitive signs of past life on Mars. We're sort of just saying that because the conditions were probably okay for it, then that suggests that there could have been life there, but we really don't know what that life might have looked like. We sort of assume microbe, because microbe seems like the simplest thing, but who knows? Okay, so there's a question about what do I think about people saying we spend too much money on space exploration? So I could go on about that topic. We learn a lot about science in general, about planets and atmospheres and humanity, like human biology, from the kind of work we do with space. Some of the space exploration we do is specifically to look at the Earth. So there are a lot of things that NASA does that are sort of Earth monitoring satellites and so on. And the kinds of insights we get from trying to keep people alive in low Earth orbit and going to the moon and things like that have been very helpful in things like water filtration and other kind of technologies that we have on Earth that help people here. And then, the kinds of technologies we build for going to space are also technologies that often have spin-offs, offshoots of other kinds of things that are not connected in really to what was done in space, but we built that technology and then we were able to apply it in different ways in different contexts. So there are a lot of, you know, a lot of things that you can learn, and like material advantages you get by studying space. But I think it's also just, you know, part of our human curiosity that we want to understand what space, you know, what the universe is like, where we come from, where we're going, like what could be the future of our planet. There's a huge amount, like there's just, you know, we want to know stuff, right? Like humans are just curious creatures, and I think just like music and art and so on, exploration, science, these are things that humans like, and I think that it's okay to let us indulge that curiosity, even if it wasn't a huge return on investment. And it is actually a huge return on investment. Space exploration is massively helpful economically on Earth. And you might not, it might not seem that way, but if you actually look into it, this kind of basic research and space research is specifically gives us more than it takes, and it doesn't take very much. We spend actually very little as a nation, as a world, on space exploration. But I think we should do it because, you know, it changes how we think about ourselves, and we learn a lot, and it's part of, you know, it's just part of the human condition. Okay. There's a question: did I enjoy The Martian as a fictional future of Mars exploration? Yes, I liked the book. I liked the movie better than the book. It was just kind of fun to learn about, you know, to imagine going to Mars. There's also a really cool National Geographic show series about Mars exploration called, I think it was called just Mars, and in that one it was a fictional journey to Mars interspersed with interviews with experts about the science, and so it got really deep into each aspect of the science of going to Mars, and also got into the ethics of it and what the society there might be like, and so on. So I would recommend that if you're really interested in this idea about Mars exploration. I think it is just called Mars. It's National Geographic. But, you know, The Martian was fun. You know, I like all those things. I love the TV show The Expanse. has stuff about Mars and space exploration, and, you know, there's a lot of fun things out there. I love science fiction in general, thinking about exploring and stuff. I'm going to take 2 more questions, and then I think I'll wrap up. Okay, there's a question: do I think the surface of the moon Titan is as habitable or more habitable than Mars? Okay, so Titan is an interesting case. Titan is a moon of Saturn, the biggest moon of Saturn, and if you look at pictures of the surface of Titan, which we have because we've sent a lander called Huygens down to the surface of Titan, it looks a bit like Mars. It's a sort of orangey atmosphere. There's rocks. Titan actually has liquid on the surface. It has lakes, but that liquid is liquid methane. It's liquid hydrocarbons. It's not water. The rocks are water. The rocks are water ice. So it has water ice, rocks, and mountains, and liquid hydrocarbon lakes, and the atmosphere is mostly like methane, and so it's super toxic and extraordinarily cold, but it's got like a hydro cycle and stuff, you know. So there's been curiosity about whether life could be in those lakes, the life that doesn't live on, you know, doesn't use water but uses these liquid hydrocarbons somehow. There's also a possibility that so we think that there's liquid water under the surface of Titan. So there's like a shell of this sort of icy surface, and then there's liquid water, we think, underneath that shell, and there could be life there too. So there's sort of 2 interesting possibilities for life on Titan. It's not habitable to us, right? Like it's a lot harder for us to live on than Mars would be, but maybe there's some kind of interesting life there. I don't know. So it's an interesting possibility. Okay, one more question. So let's see. There's a question about, can we use MOXIE to address climate change on Earth? So this is the instrument that can change carbon dioxide into oxygen. I think not. So I think in general, those kinds of machines take more energy than they take enough energy that you would have to put in a huge amount of energy to use them, and then you're sort of there's sort of you're ruining the gain you had. And I don't think you can make it a large enough scale such that you don't, it's not diminished returns. I think that those kinds of instruments are really just good for, making oxygen in places where we don't have enough. But yeah, it's interesting. There are lots of, I could go on about climate change too. So there are lots of interesting potential sort of technological things that you can do to address climate change one way or another. I think probably the best thing we can do is start using alternative fuel or alternative, energy and burn fewer fossil fuels and stuff like that. But yeah, I think one of the interesting things though about trips to places like Mars and the moon is that there are, the things that we learn from trying to live on those really inhospitable places can sometimes have useful applications for living on Earth when you're in environments that are hostile, and we have increasingly many of those environments on Earth now. So maybe that's going to be an interesting spin-off. Okay, I should stop now. Thank you all so much for coming. This was really fun for me. I hope it was fun for you. I may do more of these. I enjoyed it a lot. Thanks again, and I'll see you next time. I did say in the event description, I will be giving half the proceeds to charities working with unhoused people in Los Angeles. So I'm going to do that. I have some friends in LA who are working directly with unhoused people in Los Angeles. So some of the money will go to them, and then there are some sort of like more established corporate kind of charities as well. So I'll be contributing to those. So thank you very much for your support.